All right, so let's take an acid chloride derivative or an acid chloride, carboxylic acid derivative, an acid chloride, and let's convert it to an amide. And let's use, remembering that amides can be created using NH3 or NH2 with an R group on it, or R, R, and H. We can't use a tertiary, so this R, R, R is out of the question, and that's because we sort of need a hydrogen on there for some reason. Just remember, you need an H, at least one. And so let's just use NH3 here. And we have a lone pair on that, so it's going to be acting as our nucleophile. It's going to attack the positively charged carbonyl carbon. And that's just what we're going to do. We're going to go in and attack. We're going to kick off these electrons to go to oxygen. And that's going to give us this negative charged oxygen atom. We still have a chlorine in solution, and we now have this NH3. And I'm going to write these H's out just so we can keep track of them. And this has a positive charge now. So we want something to take that positive charge out of solution. And we could use a couple of things, maybe NH2 or NH3 to make acid. It's not very clear, but you're going to deprotonate this, and so maybe even some base would work, since it looks like we're in basic conditions, since we've formed this negative charge on this oxygen. Plus, amines are typically basic. So let's say we have an NH3 in solution, and it's got that same lone pair. So let's just use it. It's going to rip off a hydrogen. The hydrogen is going to go back onto that nitrogen. And then we'll get this. Our oxygen is still negatively charged. We still have that nitrogen group and that chlorine group. And now we only have 2 hydrogens on our nitrogen, which is good. It's neutral. And what can happen now is these electrons can go back into a double bond, and chlorine can be kicked out because chlorine is a good leaving group in this situation. And so if we come down here, we can see we still have that R group attached. We're not really worried about what that is. We formed our double bond back to that carbon. We have our nitrogen with 2 H's on it, and we've lost a chlorine ion out here in solution. And we've also formed NH4 plus. So these are going to counter each other. And so that's good. We formed this amide. This is just our products right here. So this is what we formed. So we made a basic thing. We're in sort of basic solution. What else could happen with amides? Well, we could take another amide, just like we had, or another carboxylic acid derivative, just like we had before. Still do acid chloride, or we could make it an ester even. And let's use NH2 and have a group on the N. So now we've got 1, 2, 3, and we still have that lone pair, so 4, 5. And it's going to do the same thing. It's going to attack here, kick off these electrons, and we'll get that same sort of structure, O minus. We still have this O, and now we have that nitrogen with a group on it and 2 H's. Again, now we've formed 1, 2, 3, 4 bonds, and that's going to give this nitrogen a positive charge. Okay. So again, we need to remove some protons from that nitrogen in order to get a neutral nitrogen atom, and we need to get rid of this O group here, this ester group. And again, we're in sort of basic conditions, so we can assume there's some NH3 or NH2 with that on it still, and we can protonate that, and we just take the hydrogen from here and put these on the electrons there, and now we'll get that R group still. We haven't done anything to any of the rest of our molecule, and we've got this N with an ethyl group and now just one H, and we've neutralized that. And since we're in sort of basic conditions, we can kick off this group here, and it's going to leave as a negatively charged species. We can also put the electrons back into this double bond here. So let's come down here and draw that out. So now we've reformed that double bond. We still have this nitrogen group attached. It's got an H here, and it's got an ethyl group here. And what we've kicked out is this negative O, and it's fine to be negative because it can react with some of that NH4 that we made, and they'll be counter ions to each other. So here's our products for this situation.